Right, so welcome to our session for the MG5002 Engineering Mechanics, week 3. The topic is the equilibrium of non-concurrent forces. Today is Friday, the 8th of March, 2019, and as we agree, we deliver this course at 1 p.m. And it looks like it's working really good with this weather, so hopefully all of you are from home or from Wintec campuses. I'm at the moment at home, so I will not be able to help you. But if you have any issues, just feel free to send me an email or contact me on my extension number, and we'll get to my mobile number anyway. So if we just give an idea, the topics we'll try to cover today. So the first topic will be examples for non-concurrent forces. And then we'll do a second topic, which is truss analysis, which is a very heavy question. We'll go through it. Those are the most important topics. So 2 examples for non-concurrent forces, and 1 example truss analysis, which it's not necessary, it has a mix between concurrent and non-concurrent forces. So the truss analysis is kind of an application where we can apply both methods of calculating forces and moment. All right, so let's start with the first example. I choose an example from the lecture notes, but I will try to do many questions through this example and try to go through different ways to address the example and give some challenges for it. So determine the moment MA. First one, he wants you to determine it in the way of clockwise. Okay, you can see it in the direction of the arrow, clockwise, and the moment around point A, anti-clockwise, so the opposite direction. So you have a beam, let's say this one, A, and then this point ends, it's supported by 1 support reaction at this point, R. It's obviously supported at one end at A, so it's a fixed support. There's 8 kilonewtons going downward, so it indicates for me what's the direction of going downwards as a force, which is in the y direction negative, and there's a force 10 kilonewtons inclined with the 45 degrees angle. So the first thing, when we try to solve this kind of questions, we need to understand how can to work on it. Hey guys, is there problems? Can you hear me well? Because some of you say we are not able to hear me. So can you hear me? If you can, just type to me if you can hear me or not. So, okay, so the rest can hear me very well. So just if you have some issues, please, maybe it's your mic or just check that, because obviously, please don't type on the screen. Please don't do it. It will be really ugly. So if you can remove it, just go to the pin and remove it, because it will really be ugly. Right, thank you very much. So, okay, so if you can't hear me, then some issues in your device or you don't have the right settings, please check it. But anyway, let's continue for the example. So if we try to find the moment around A in the direction of clockwise, so the first thing we start here in this kind of questions is to draw or sketch a free body diagram. So I will try with that first thing, so it's to show what's components of forces we have in that direction. So first of all, we take the beam itself in that way, and we will show the support reaction forces. For example, here it's 1, and there is another one around this point, and there is another one at this point, and of course they have different magnitudes. And there's also very interesting, this support reaction at that end, which is a fixed support, is giving me for some interesting things which we need to explain it more in the next topic for next week. It actually indicates for me two supports. So one is going as fixed support we treated, but also there is something is indicates for me kind of a moment to prevent any rotation. So if that force R try to rotate that, here this support wall try to prevent that rotation. I'll explain this in next week's session. So I will delete at the moment this one, just I will delete it because it's not part of the topic we're trying to discuss today, and I will explain it definitely next week with a new topic. So we come to A. Now, since we want to take the moments about A, so technically I will not take into account the forces here because they are passing through the point A, so technically they are zero. Well, I'm trying to put the components of the forces. But if we say we're trying to do it as a free body diagram, definitely I need to indicate there is an AX and AY here. So I will label all these forces so to make sure I have the right. So this is 8 kilonewtons, and this one is 10 kilonewtons, but I need to see how it works. But at the moment, we're just doing the free body diagram. And this one, it's R, so we don't know the value of this force. And here I have AY, sorry, because it's going in the Y direction, and the other one it's AX because it's going the X direction. All right, so what we call the first step, this one, it's a free body diagram. This is the first thing you start. So one is free body diagram. Now, free body diagram, it's really good and helpful for us to show the dimensions or the distance, and how can we demonstrate where is the forces located. Some people, they would say, is it important to show it? I mean, it's good to show it because it really indicates, will help us as well to calculate anything. So let's say this is 2 meters as shown, and Control C, Control V, and this distance is about 1 meter, and Control C, Control V, this is about 1 meter, and then we just put the arrows there. By the way, I will share the slides at the end of the session with you guys as well. So very easy, free body diagram is showing all the components of the forces acting on that way, 10 kilonewtons. Don't forget the angle, it's just located so we can understand it's 45 degrees. So it's just helpful for us to locate it in the way so we can understand where is this angle going. Before I continue with this question, I'm just seeing who's there. So we got, hopefully, Webin, the system is working for you at the moment. We got, so who's LIP? Please, if you can give a name so I can take the attendance. And Jack is there. And yeah, yep, it's good, it's working. So Ranjit is there. So I'm just trying to take the attendance. At the moment, we have good number, 12 people attending out of 13. That's a really good number. All right, so if we continue with this, and I will give you time to ask questions. So the first step, we converted to the to this diagram. It's giving to us as a free body diagram showing all the components we're trying to address, and we try to analysis in the direction. Now, remember, this force, because it's inclined at this point, I will change the color for it so you can see it through. Just make it, and I will make it really good size so at least you can see it. So this force, let's say, and this is the angle is acting, then we need to write the components of this force, which is 10 cosine and 10 sine. So if we Control C, Control V the arrow just for a second, and imagine you're trying to do it in your paper would be a bit. So you need to be a bit organized when you're trying to do these things. I would give a different color to show you that this is the component analysis. Now, if you ask me, is this part of the free body diagram? The answer is not part of the free body diagram. But what I'm doing at the moment, I'm preparing my stuff for me to make my life easy, so when I can solve the question. So definitely what I'm doing at the moment is not part of the free body diagram, which is everything in let's say in the red color. And then I have another components of the force, which is going downwards. It's kind of the analysis of that force should be on top of that. So if we write the first components for that one, so I will just generate a new equation here. And let's say it's tan and cosine, and the angle is 45 degrees. I'll write it in red so you understand this is not part of the free body diagram. This is for that one. And the other one, which is, I would just extend the length temporarily, just to not confuse you with other things, will be definitely tan sine 45 degrees. All right. Now, if you look carefully, if we try to take the moment around the point, what we say, we need to see the line of action for the force. So if I want to do that, I will draw this line and I will make it as disconnected line, and I will change the color so you can see it very clear. I will make it even clearer. That's the direction of the action line for that force tan cosine 45 degrees. It's actually passing through point A. Therefore, the components of tan cosine 45, it's multiplied by the distance. The distance, if it's passing through the point, is 0, so there is no moment for that force. Therefore, we don't take it into account, this one. So that one, technically, we're not taking into account. Now, if I go back to the question itself, I want to find the summation of moments around point A, clockwise. All right, so we start a new equation. Hopefully this as well will help you as well in the future when you try to do your presentation. Now you're learning a new skills how to type equations. So again, moment around point A is equals to what? And I'm doing firstly the moment around, we don't need this, around, oh, sorry, the moment around point A, it's clockwise is positive. So what we have in this equation, the first thing we have, we need to see all the forces will turn the object clockwise. So the R, which direction do you think the R will rotate? Can you type, please? The force R, which direction will rotate the beam, this blue beam? So I'll give you time to write. So what do you think the R, the force R, which direction? So I start getting some good answer. Yeah. Yes. So technically, it's not considered. So the question, which force will turn the beam clockwise? Let's make it in that way. Yeah, perfect. Yeah, good answers. So which force do you think, or which forces, they will turn the beam in that way, in the clockwise? So if you look carefully, we have the tan sine 45. So write the equation here, tan sine 45. Please make sure to insert the degrees, because you know we may confuse ourselves and then we find like we solving the question in radians, which is not correct. Now this is itself is a force. What's missing? Tan sine 45, it's a force, so we just did the components times the distance. Perfect. So what's the distance? We have 1 plus 2. 1 plus 2 from here to this point. So remember the perpendicular distance to the point. So I will write 2 plus 1. So at least later when you see the video, you understand it's 3, but where this 3 coming from? It's 2 plus 1, the distance. Plus, also the other force will turn it is the 8 kilonewtons times the distance. The distance is 2 meters. So this force, the 8 kilonewtons, will rotate the beam A clockwise and with a distance 2 meters. Now, if you solve that, you should get the answer. I'll give you time to solve it, and you can tell me or type me the answer. So sine 45 times 10 times 3 plus 8 times 2. So the answer is, many of you try getting it. Yes, so the answer is 37.21. And please, guys, now we are week 3. I don't accept any answers without units. So it's a warning message now. Any answer without units, you miss marks, okay? It's not anymore. We're not in the first week to say we don't know to do these things. So is the answer just kilonewton? Is the answer correct? I just getting the answer from one of the students. Is that correct? Do you agree on the 37.21? Perfect. It's not kilonewtons. Kilonewtons meters. You need guys to see. I'm now receiving many answers. Sadly, many of them just saying it's kilonewtons. Please look carefully. What we found here is the moment, is not just the force. So because what we're doing, force times distance plus force times distance, that means the answer is kilonewtons meters. So the guys who are answering only kilonewtons meters, if you do that in the test of the exam, you will definitely lose marks. Moment has different units from a force. So please pay attention to those small, tiny things, because you don't want to misguide anyone reading behind you when you try to design something. All right, so that's the moments in the direction of clockwise. Now, the other part of the question wants us to find the moment in the opposite direction, which is anti. So what I would do, I would just copy my equation here, and I'll bring the sign. It's very important to bring the sign, because without the sign, we will not understand what are we trying to do here. So it's very important to show what we're trying to achieve to anyone. So we'll bring this here to make sure. All right. Let's type the equation. Looks like it's acting funny, a bit funny. So you bring here algebraic summation, and here you just use the scripts and then use m around point A, and we don't need this. All right, equals. So now we want the moment on the opposite direction, so which is anti-clockwise or counterclockwise. So what do we have? The only force will rotate that is the r, which the r will rotate the force in that way. So technically is going in that direction. Therefore, what's what I have? I have r as a force times distance. What's the distance? 2 plus 1 plus 1. So the distance is 4 meters. So from r, rotating in that way, you have 1 plus 1 plus 2, which is 4. All of that equals to what? Remember, equals to the answer we found earlier, 37.21. But we don't want to find that. We just want the equation. So the answer is for R. Remember, read the question. Determine the moments counterclockwise and clockwise, and he doesn't want you to find R. So what is confusing you guys here? Some of you trying to find the value of R, but we don't need to find the value for R here. And that's what some of you need to read the question very carefully. And then when you say for R, the moment is for R, then that will be kilonewtons meters. So it's really seriously, half of, like, if you want to really answer the questions correctly, half of the process is understanding the question itself, and then you do it. So there is a question, if we do solve for R, will we lose marks? It's not really loss of marks, we're not trying to do, but you're indicating that you're not really understanding the question itself, because there's a big difference when you say find the moment around A or find the value for R. So if we say now, we added another part, find the value R. So find the value of force R. That's, of course, that's now its or value or magnitude. Now, yes, of course, that's now 4R equals to 37.21, and if that's divided, will lead you to to find it. So it would be R equals 37.21 divided by 4. And that's the answer is 9. Oh, sorry. The answer is 9.3 kilonewtons. That's different. But see, we need to have a different question. We need to read different information. So that's a part what didn't exist in the example. So I will say it's not necessary you lose or you gain marks, but you need to be just careful with that. Otherwise, will lead to wrong information. I didn't get your equation, so I'm just a bit confused. So some of you, I'll start responding on the chat. I didn't get that equation, so if you can look into it anyway. Okay, I got your point. Yeah, okay, I got it. I got it now, yeah. But again, it's very important to really answer the question as long as showing all the information there. All right. Please, can you explain why 4R will be equal to 37? Okay, because very easy. Because the moment at A, it only has one value. It's just we're finding the value from two different ways. So either that moment, the first equation we wrote it is just to give us the value, and the other one is to solve the equation. What is missing here, which I'll explain it in more details next week with the new topic, that support reaction, it's create a support reaction force rotating that way. So that moment, MA is actually try to rotate the beam in that way to prevent any rotation from the R, which is the 9.3 kilonewtons, to drop it to that way. So kind of there is a support reaction and there is a moment to avoid that bending. This is a topic we'll go in more details in it. So technically, this MA, we found the value. Now what you got, the MA equals 4R. We know the MA what's equals is 37.21. Just substitute the value. So 4R is equal 37.21, and then rearrange the equation and you find the value for the support reaction. I hope that's clear now. So technically the moment, whatever, it's a system in equilibrium. So if you find MA is only one MA, it has, at the moment, is just the direction to prevent the beam. So let's say if R was really big, what do you think will happen? A start will push the beam from that end and try to rotate it on the other direction. But that wall here, trying to prevent that to give us the equilibrium so it doesn't happen. And I'll give you some examples because this actually is our topic for next week. All right, so any other questions before we move to another example? Is an clockwise force equals clockwise and clockwise force equal clockwise force? No, the question should not be that. The question is, we use clockwise moment, not force. So the moment should has the same value, whatever its direction, but where we're trying to achieve it is just to tell us how we're addressing it. So to answer you, the question is not the force, is a clockwise or anti-clockwise moment equals to clockwise moment. If in this case, yes, that's what we've proven, but not force, a moment. All right? Yeah. Cool. Do AX and AY hold any significance in the problem? Yes, they do. Of course they do. So that's a very, very good question. Actually, you said very, very good question. This is really, I will read the question again. Do AX and AY hold any significance in the problem? Of course, yes. And I'll show you by this example. So I will take this slide again and just copy it here so I can show you this. We don't need these equations anymore because I want to explain this question. Really, it's a nice question. So let's put this question here. Close it. This is the question I got. So I'm trying now to go through it step by step because really this. Now look to the system. What do we have? Here you have AX. So this is AX. I will take the forces just to show you. This is AX, right? On the X direction. Do we have any forces going on the X direction? Yes, I do. Which one? The red one. If I can hold it. Oh, come on. Yes. What's the value for that? It's 10 cosine things. So technically, AS, if I put a sign here, AX equals to 10 cosine 45. What's mean? Any forces opposite to each other direction, they're trying to create the equilibrium for me. So AX here in this example is equal to 10 cosine 45. And that's what we're trying to say. So that wall is actually supporting. Now, why it's happening? Because 10 kilonewtons is came with an inclined with an angle. Therefore, the AX is trying to stop that pushing. So it's kind of giving me the support, which has the enough value equals to 10 cosine 45 degrees. That's the first step. So that's kind of which equation represent for me here, which is going back to the first topic, concurrent forces. So if I say forces in X directions equals to 0, so if X equals to 0, and that's the equation for that part. Now, if we done for the X, we need to do the same thing for Y. So if I do the same thing for Y, algebraic summation of forces in Y direction, so F, and I will put the scripts to show you Fy equals to 0. Now, to write that, let's look how many forces I have in the Y direction. I have AY, and I have 8 kilonewtons going downwards, and 10 sine 45 going downwards, and R going upwards. See, that's an interesting thing. So you have 2 forces going up, 2 forces going down. So if I want to write this equation, I will equals, so I would say AY minus 8 kilonewtons minus 10 sine 45 degrees, make sure, plus the R equals to 0. So from this, I will definitely have a value for AY because we already found earlier the value for R, which is the 9.3, that's the value for R. And therefore, if this equals, after we find the solution, 9.3 kilonewtons, therefore we can find the value for AY, and the same way how we found AX. So definitely, they are doing actually a lot of jobs, and we see it. It's actually our topic for next week, which is how we calculate the shear force and bending moment diagrams. But it's really very good question. So when you have this kind of forces here and there, we need to indicate them because they are part of the equation. How can we represent them in equilibrium? Because everything should be here in equilibrium to support each other. Now, that's a question. When asked to determine a moment, doesn't this mean find the value, not just the equation? Yes, of course, find the value, but we already found the value in the first part, which was the 37.21. And the second part is just to show you the value is for that, like the other parts, because it's unequal. So you need to determine R and then you work with it. So, this is something, gonna get my computer set up so my camera won't be on. Don't worry, it's the camera is mute, so you don't need to worry, it's not showing anyone. Any other questions before we move to another examples? Those are really good questions. Right, no questions, so let's move to the next part. By the way, I just solved this example earlier in the slides to show you things how it works. And let's try this example. Example 2, a lever ABC, you can see it here, ABC is held in a vertical equilibrium by 3 rods, 1, 2, 3, which pull on the lever with forces as indicated. 1 Newton, 100 Newtons, 200 Newtons, and P, we don't know the value. what must be the value of P if distance AB is 1.3 meters and BC is 2.6 meters? I just move this sketch on the side so we have a space. Now, first question, what is step number 1? Now we should know the step very clearly, of course. So 1 is free body diagram. Now, free body diagram, of course, will be for the beam ABC or the lever. So we sketch something similar to it. So when you start working on your exam paper, you just get something same length. You don't need to have circles at the end of it. I'll change the color to make it looks easy for us to see. And then we will try to explain what will be next. How can we show the forces? So we bring first just an arrows to show the forces here. That's the 100 Newton, Control C, Control V, and there is a force on that line. See, we need to make sure it's going through the center line of the point. So I will sketch a line here. I'll put that center line here in the middle and double click on it, and I make it as a center line because we need to understand what's going on. So you can see that tiny center line. Now we have another force. Let's change the color of this force and so we don't confuse ourselves. Just copy this line, change it here. I'm bringing this force to this point and make it like that way. Now I need to put the values, part of my free body diagram. So this one is 100 newtons. And for me, it's easy to copy this and then change the numbers to save my time. P. So the forces, now I need to label the bar so I understand where I'm working. This is A, and B, and the last one is C. Now, if you do it till here, free body diagram, I'll say, hey, you're missing a lot of things. What's you missing here? You have a fixed support at this end. So technically, we need to have the forces at that end. So that's very, very important because you're drawing a free body diagram. So we have a force going in that direction, and I'll assume there is another force is going in that direction at the point C. So we do it here exactly where is the point C located, and just make it looks better and more organized. And one we call it AC, and the other one, CX and CY. So this one is CX, and this one we call it CY. It's kind of one going in the Y direction, the other one is going in the direction. The other things we may need to just put for us is easy for us to remember. It's the direction of the angles. But here is some tricky things we need. So one is 60 degrees. We place it here. And here is the question. I will highlight the points to show you how can we determine the angle between the 100 and 200. So if we have a straight line, just like this, make it disconnected line so we don't confuse ourselves with the forces. Look carefully here. If the distance between here and there is 45, so this, we know it. I'll copy the number, 45. So if this one is 45, what do you think this distance is equals to? 90 minus 45 is equals to 45, of course, perfect. Now, if that 45, oh no. What do you think then this between 100 and the disconnected line? If the total of that is 60, 60 minus 45 will be 15, perfect. So you technically, if you get confused with them, just split the numbers so you can make life easy. So now that explains to you, if all of that's the total was 60, and we know this is a 90-degree angle, we have 45, the remaining of that is 45. We know the total between 100 newtons and 200 newtons is 60, minus 45, the remaining is 15 degrees. You work it like this, you get the angles very nicely distributed, very good. So this is a free body diagram. It's showing the angles, the direction of the forces, and we haven't done the components for it yet. So that's step one. Now, step two, we need to go back again and read the question because we don't want to confuse ourselves. So remember, we need to allocate the distance as well. So I'm just putting the distance to make sure we don't confuse ourselves. So an arrow here, it's very important to show those dimensions. So let's do this, Control C, Control V. So from A to B, it says to us is 1.3 meters. And from B to C is 2.6 meters. Of course, I'm not sketching to scale, so you see that's funny numbers here or there, okay? Like, or the dimensions are not to scale. Make sure to say that. So that's the kind of like the free body diagram is showing all the relevant information. If we finish from the free body diagram, then the second step, we try to go and find the value of that force acting with 60 degrees in that direction. So I'll highlight it in red to understand what we're trying to find. What must be the value of P? This is really very interesting question because it has a lot of understanding. Now, the easy way is to first to solve is taking non-concurrence methods theory and try to solve this example. And part of it, we need to write the components of the force. So after finishing from the free body diagram, step two, we need to write the force analysis, the components of the force. So I'll get another arrow just to show you. So we start with the first force. We'll give it a color red to distinguish between the forces. This is for the 100. And I will say this force is 100 cosine 15 degrees. I'll write it in red so we understand what force. And there is also another force on that direction from the 100. I will call it 100 sine 15. So kind of we did the analysis for the 100 newtons. Now, the 200s also had something similar to that. So I will add another arrow for the 200s. I'll put it just here and I'll show you how can we do it. Remember, if we have an extra force, we add to the back at the end of that arrow. So kind of here, we have, let's make it in green color and something maybe like this so you can see it very clearly. So that force, it's 200 cosine 45. Of course, in degrees. I'll highlight it in green so we understand what we're doing here. And there is another component for that force. It's going downwards. I need to make sure my arrows are really in the right direction. Coming here, and that one will be sine. By the way, I could keep it sine and cosine because remember, this has only happened. This is a note for you guys, which you can try it in your calculator. Sine 45 degrees is equal cosine 45 degrees. It only happens when you have 45 degrees because it's kind of looking middle in the angles, okay? So this is something for you guys just as a note. So if by mistake I wrote cosine 45, it should be fine. I should get the same value, because if you look at it, it's opening cosine and sine on the same direction. It's a half an angle. All right, so that's the components for that force. Now what's missing is the components analysis for the force P, the one we're trying to find. So I go and try to do again another error. So that would be, I would just do it here, and I would give it maybe this color, and then I'll try to make it easy to see so you can see it. And I'll bring that one here, and then will be, we know this force is equals to P sine 60 degrees. Let's change the color to something matching the color of the force, and we bring it this here. And now I have another one here, but that one will be cosine 45 degrees, so cosine. So now you ask me a question, is this part of the free body diagram? The answer is not really. This is only to help me when I try to solve the question. I know all the analysis and components for the forces, which now I highlighted as in red and green and the orange color. So now when I try to solve this question, I should know what I'm trying to do. Now, other question comes to you, hey, do we need to know the value for CY and CX? Yes, if they want you to find them, but if you take a moment about C, then these forces, they will cancel. So now if we say, if I take a moment around that point, you see this force cancel, this force cancel, this force cancel, and this force cancel, and this one as well, because all of them, they pass through the point C. So it looks like taking a moment around C, around point C, is the best solution, because many forces will cancel, and hopefully we'll find the value for the force P. So let's do that. Now we got it in the direction, so we write the equation. Algebraic summation of forces, algebraic summation of moments, sorry, not forces, and around point C. So M and C equals to 0. I'll bring just this equation here so you can see it very clearly. Now the question, I will leave it for you. I will leave the majority to decide. I'll go back to your question very soon after finishing that. So what's the question, or sorry, what's the direction? Do you want it clockwise to be the positive or the anti-clockwise? So just take that one. I will assume clockwise is positive direction. So I will look to what is rotating clockwise will be positive. Let's start with the first one. What we have, all the forces again, this one, this one, this one, this one, and this one, since they pass through point C, or the line of action passed through point C, the distance is equals to 0, therefore the moment is equal to 0, because anything multiplied by 0 is 0. Then what's left? Left for me the red force and the green force and this orange force. So technically, an equation with one unknown, which that's what we're trying to find. So let's try to solve this one. So what will be, if we continue writing here, so that's, start with the top one. We rotate the geometry clockwise. Yes. So it would be 100 cosine 15. What's the distance for that? So it's from 1.3 plus 2.6. Plus, we have the green force, which is 200 cosine 45. So it'd be 200 cosine 45 degrees times the distance. What's the distance equals? It's the same thing, 1.3 plus 2.6. So the distance from the action of the force till point C. Now, what's next? This force. If you look, both of them, they're rotating the level clockwise. This one will rotate it anti-clockwise. So it will be minus B sine 60 degrees equals to 0. So now we generated one equation with one unknown. It's called the force P. So you rearrange this equation, and I will give you time to find me the value for the force P, and please state the units. Who joined us? We got R and G with Paul is here. Cool. Wow, good. We have full class, 13 of you online. That's awesome. Should P sine 60 not be multiplied by distance? Awesome. You are the smart person. I'll not say your name. Yes, times 2.6. Perfect. Perfect. So, guys, always remember it's force multiplied by distance. All right? So always remember, see, even me, I can do this mistake and I can't write the force. Why this mistakes happens? Because we know the force is P, and we sometimes by default we treat the sine 60 as a distance, but in reality, no, it's just the analysis for the force. So this is really very good spotting. Thank you very much. So I'll give you the time. You just put this in your equation. Remember, everything is in degrees. You can switch everything and then get it. And you can try it. Any answers? Looks like very complicated equation. My advice for you guys, when you try to solve this kind of equations, or bring my calculator, I will work it step by step. So what I would say the first one is cosine 15, and that's number times 100 times open brackets 1.3 plus 2.6 close brackets. So that will give me 376.711 plus, and then I work, the other one is cosine 45 times 200 times 1.3 plus 2.6. That will give you 551.54 minus, and then sine 60 times 2.6, and that will give you 2.25. P is equals to 0. So in this way, you see the equation, it looks really nicer. And yes, correct your answer. No, the unit is wrong. Try to think about the units. Try to think about the units. And then you rearrange this equation. So what will be the force P is equals to adding together our open brackets 376.711 plus 551.54, all of that divided by 2.25. And the answer is, come on guys, I'm waiting for the answer. I haven't got any answers so far. So 376.711 plus 551.54, all of that divided by 2.25. So the answer is 412.556. Now, here's confusing. Some of you answering it in different ways. First of all, some of you saying it's kilonewtons. No, it cannot be kilonewtons because remember the forces are all in newtons. And some of you answering this is in newtons meters. Remember, we're trying to find the force, not the moment. The answer is 412.556 newtons. I'll just put this up so it doesn't confuse the slides. It's a bit funny. It's here. So the answer, it's in newtons. I know if you have been seeing this answer model, the answer model is showing kilonewtons. It's not correct because if you look to all the forces given to us, they are in newtons. So the answer must be in newtons. And therefore, that's what's the right answer. It's 412.556 newtons. Now, why you say it's newtons? Because remember, we're not finding the moment. The moment is that's represent the moment times 2.6. So if I multiply that by 2.6, that will give me the moment. But no, what we're finding is the force. That's what must be the value of P if distance AB. So that P, as you see, is a vertical equilibrium of 3 rods which pull on the lever. So that's one of the forces trying to pull the lever. So again, place units, you need to guys revise them all the time. It's newtons, and capital newtons is also very important. So kilonewtons, newtons is always written in capital letter N to not avoid you. So I'm giving you some of the feedback, but it's good to see you guys trying it and giving me the answers. I have seen a couple guys doing the participating on the chat, but I really try to see the others. Now, I got a question. I'll bring the question here, which I postponed it. I say I will answer it later. So let's put it in red so you can read the question. What was the rule of determining the sine, cosine, tan of a resultance? For example, force P has a different sine and cosine compared to A and B. Okay, that's a good thing. Since it's leaving that point and the angle is here 60. So what we learned here in this question, when you go from the direction of the force towards the angle, it's always cosine. When you go away, far away from the angle, like that direction, use always sine. So that's the easy way. So again, from here towards the angle, P cosine the angle, 60. Going away from the angle, P will be sine 60. That's the easy way to remember it. So going towards the angle, use cosine, kind of like you're going a curve. So that's the C indicates for you a curve, if you want to make it like this. Going away from it is sine. It's not a curve. It doesn't have the word C, so you're going away from it. So going towards the angle, it's always cosine. Going away from the angle, it's sine. And this way will be easy way to remember it. Is that answering your question? Cool. Perfect. So this is another question which is showing you different ways. Again, it's showing you that when you use the M, the moment around the points, that's what we call it as non-concurrent forces. If you see in this question, we didn't use summation of forces in X and Y direction. But now I will ask you guys the similar question we got last time here. Where was that question? I think I had it here. Yeah. If we go to this question, sorry, where I was? Yeah, here. Cy value is equals to what? Cy is opposite to what? P cosine 60, opposite to 200 sine 45 degrees. So kind of there is equilibrium. The Cy is giving support against two forces. P cosine 60, which is 412.556 cosine 60, plus the 200 sine 45. And on the Cx direction, what you have Cx pushing in that way, but you have 200 cosine 45, 100 cosine 45. So if we do the equilibrium, and this one is 412, 55.556. So it's possibly I assume the direction of CX wrong. So I need to find the equilibrium for forces in the X direction, and that's what correct my answer. So that's when you're trying to find, if I say on the same question, like something to update the question, make it looks more interesting and longer, find the values for CX and CY. Values and directions, of course, and say if they are tension or compression, T or C. So that also could be a good things to explore. When it becomes that like this, you'll treat it as a concurrent forces, because what you're using a summation of forces in the X and Y direction, and then you solve the equations and you determine the value for CX and CY. Again, this topic will have a good examples about it next week when we do the shear force. Any questions before we move to the last example? Last example is a bit heavy, it's a bit long, will take a while. So I'll give you time for asking before we move to the next question, truss analysis. All right, no questions. Let's move on then. By the way, I did the slides earlier and showing the step by step. And here is showing it for you guys step by step. So later you can see the slides step by step going. All right, example 3, truss analysis. Looks scary, right? Like, wow, this is really something different. Determine the force in each member of the truss and state if the members are in tension or compression. We try to do as much as we can, but again, I will share with you the slides later because I solved this question step by step, and maybe I have I have done a mistake at the end. I want you guys to discover it. All right. So this is truss analysis. You have a different members. Each one of this, we call them a member. So AE, ED, DC, CB, BE, and BA. They could be connected by joints. The joints, we call them joint A, joint B, joint C, joint D, and joint E. It's fixed supported at C. It's a roller support at D. And distance is given. Possibly we may need to give you the distance from here to there, which I will add it now. Half of that distance, so from here to there, it's 2 meters. Okay, so there's a distance for that one, that line, from that point to that point. Yeah, so that's kind of like halfway is 2 meters because it's identical and has 4, 4, and looks like the dimensions. It's just my arrow went really funny. Right, so this is a very good example because it will test us how can we apply both theories, concurrent and non-concurrent forces. Concurrent forces could be used to find the support reactions, and non-concurrent forces, sorry, can be used for finding the support reactions, and concurrent forces can be used to find support reactions plus the forces on each member using the joint methods. And also there is a section methods, which we will talk about at some stage. All right, so the first step of this question, I'll make a new slide, show you. Once again, yeah, I know I'm saying it too much, but it's true. First step is free body diagram. So if this is a free body diagram, I need to take this geometry again and remove all the forces from it, or sorry, those fixed supports and roller supports, and change it to be like a type of force. So I will do this on top of that. So I will select an arrow in that direction. I'll just make it clear you can see. And in the color, we change that to red. So let's say this one represents for me, maybe make it bigger so we can see it there. This one, we call it CX, based on the support. And another one on that direction, we don't know, but we assume in that direction, we call it CY. And since we did that, we remove the support reaction. We say we replace it by two forces, CX and CY. Now, when you have a roller support, how many forces do we have? Can you please answer this? No. Do you have 1, 2, or 3? Just choose a number. No. Yes. No. Yes. Of course, I'm saying yes or no, and no one knows to whom I'm saying yes or no, since the answer is coming very well. All right. Simply, it's a roller. Remember the chair we did in the class? The wheel is only touching the floor on one force. Even they show 3 wheels, but we treat it as one. So you remove all this together and it's treated as a one support reactions, what we call it dx. Very easy. So dx. I'm trying to confuse you here with things, but that's how they look like. So it's only one force is dx in the x direction. There is no force in the y direction. All right. So if you ask me, is that all about the free body diagram? The simple answer, yes, that's the free body diagram. We take the truss analysis overall, and then we took off the support reactions. We keep the forces, external forces. You have 4 kilonewtons acting at that point A, joint A, 8 kilonewtons acting at joint B, and 4 kilonewtons acting at joint C. And here you have a support reaction CX and CY, and you have a support reaction DX. Step 1 is done. Free body diagram achieved. So this is done. Okay, now how can we move further? What do you think is the best way to address this problem? I'll give you time to answer. So if we draw the free body diagram, what's next? Any answers? What's next? Find or calculate the support reaction forces. CX, CY, and DX. That's the second force analysis. Before force analysis, we need to determine the support reactions. So those are the one I highlighted in red. We need to calculate them because they are acting as a force on the body or on the system. So how can we do that? If you look, CX is equals to CY. No, sorry, CX is the opposite direction of DX. Kind of we need to take a moment around point C, and then we can determine the value of dx. So very easy. We say write equation, find the moment around point C equals to 0. And what we assume clockwise is positive. So if the moment is going in that way, what's necessary for us to determine is all the forces will rotate clockwise. So the first one will rotate positively. If we write that down now, which one is dx times what? What's the distance between dx and point C? If you look into it, is 4 meters. Now, that one will rotate the geometry or the truss in that direction, clockwise, but the 4 kilonewtons will rotate the geometry, if you see the direction for it, anti-clockwise, so it will be minus 4 times. What's the distance? From here to C, it's 4 plus 4, it's 8 meters. Minus, there is also another force, is 8 will rotate in the opposite direction, so it's 8 times the distance from that 8 kilonewtons to C, it's 4 meters, as indicated here. And then, is there anything else there? No, because 4 kilonewtons pass through point C. This forces pass through point C. So technically, these forces, they don't have a distance, or their distance is equal to 0, because the line of action, it's not active when you take the moment. So we say equals to 0. This, rearranging this equation, will tell you dx equals to, so you just arrange, will be 4 times 8 plus 8 times 4 divided by 4. That will give you 16. What's the units for the force here? Kilonewtons. Now, we found dx. I can update my diagram and I say this is equals to 16 kilonewtons. Now we need to determine Cx and Cy, because that's the second step we're trying to solve here. So the best way, if you see, we can say summation of forces in x direction Fx equals to 0. And that's the direction is positive. So what do you have? You have dx, which is 16 kilonewton, this one. And this one is minus Cx equals to 0. But in reality, the assumption of minus is wrong, because both of them going in that direction. So if I assume this is minus and this is minus, because if I assume my positive direction is going in that way, so I need to make it clear. See, that's why maybe some of you will start feeling like, oh, what's happened? What's happened? It's confusing. Yeah, I agree with you, because I didn't put the arrow earlier to show you. So this is the positive direction of x. Now, the red one, dx, is going negative. Cx always also indicating negative. Therefore, Cx is equal 16 kilonewtons, but the direction of it is tension. It's not anymore compression. So I assume Cx going as a compression, but in reality, it should be tension, should be going in the other direction. How did I know that? Because when you solve this equation, it will correct the answer. It's giving you originally in the answer minus 16. And then you say, therefore, then Cx is in tension. Rule, we say, when we get a negative answer, it's mean whatever we assume is on the opposite direction of this assumption. So now we found this one. We can correct the diagram for me. I will correct it just now, because this is a live video, so you can see it. And Cx is equals to 16 kilonewtons. So I'm correcting it in there. In your paper, you don't need to do it that way, because you will follow it up by just writing then Cx is in tension. All right? And it means Cx is 16 kilonewtons. All right. Now, summation of forces in y direction, because I need to find cy. So I repeat the same equation, summation of forces in y direction. So Fy equals to 0. And then what we have here, we have that force is just to say all forces going upwards are positive. So that's the arrow indicates what I'm trying to achieve here. And then we try to write the equation. So what do we have going upwards? We have Cy minus 4 minus 8 minus 4. Very easy. One force is going upwards is the red Cy, and all the blue forces going downwards. These are the only forces acting in the y direction. So Cy is positive, but these guys going downwards, therefore they are negative. So now Cy, then Cy is equals to what? The summation. So 4 plus 4, 8 plus 8 is 16 kilonewtons. Very nice answer, actually. All the forces are in kilonewtons. Now you say, hey, then what's this force? It's compression. Because we got the answer as negative, then it's compression. What about the x? It's also in compression because the answer, it's positive, therefore the direction of the assumption is correct. This is how to find an application for concurrent and non-concurrent forces using one is the moment, the first equation, and the second one is summation of forces in F and X. This is very important to say that this is my positive X and this is my positive Y. So one of the things you need to indicate always in your paper for the marker or anyone reading your solutions. Let me copy this one, Ctrl-C, Ctrl-V. So this is represent your X direction, positive, and this one represent your Y direction, positive. That's why I assume this. Again, as discussed in the class, you can change this on the way you like it. It's your own options. I will give you a break now just to understand. If you have any questions, go and read the slides now and see if everything is clear, or if you want to ask any questions, feel free to ask. I'm waiting for you in the chat to ask any question about this. Are you guys there? I hope I didn't lose you. Can you hear me, guys? I'm working at the same time, but still following what you're doing. Yes, we can hear you. Perfect. All right, so if you have any questions, just ask me so I can help you. And if you're working on it, I will give you time to find it. I'll just get a glass of water because I start losing my voice while you're working on it. All right. Would you redo the fx equation but not flip the direction of the force so the value will be negative? It's recommended to avoid any confusion. It's always to keep it in that way, technically. and then you do the equation. You don't need to resolve it again. You just say Cx, it's a negative, or Cx is in tension. So in this way, when I read your paper and Cx, I understand it should go in the opposite direction. So that's where it's negative. You put there. Or Cx is in tension, so I understand the Cx is leaving your geometry. Yeah, I know. So that's the communication for us, is to say Cx is in tension, so I understand Cx is leaving point C, is not going towards point C. Or Cx is minus 16 to show me that, yes, I can see it in the diagram, but it should be on the opposite direction. So it depends how you do it, but because this is not the end of the question, so you should really work on whatever you found. Otherwise, will confuse your answers in the next step, because next step is to do the analysis by joint points, and I'll show you about it. By the way, guys, if you can just pay attention here, I will show you some very good things. This topic, it's very, very important. I'll share my screen at the moment with you. So we're going to Moodle course. So I don't know how many of you have seen this. The topic, equilibrium of non-concurrent forces. And then if you see post-class activities, I have done these examples last year. So truss analysis of example 1 and 2. And then truss system activities. So these are YouTube videos. It's short videos, like 15 minutes, less than 15 minutes actually. It's just to explain to you some of the examples is done in the past. And for different application for truss analysis, again, less than 15 minutes, and explains in the same way, step by step, and I work the examples. And the good things about them, these videos are very short, like not really long lectures, so it's good for you to watch them. And the last one is this one, which is also truss analysis, and you go step by step with them. Yeah, someone saying is going to spam these videos. So yeah, so it was really helpful because this topic is called the truss analysis, and it show you how it works step by step. So I've done these videos last year, and the students, they found them very helpful. And what's is good about them, so one is 10 minutes, the other one is 12 minutes, and the third one is 14 minutes. And they're really good because I explain everything in them in a very basic, and you can watch them like a short, not boring. Like what we're doing now is a long lecture, so it takes time. And there are a couple of examples. So if you missed here anything, so you can click on these truss more examples. You can go through them. And the one we're trying to solve is the last one, this one. And we go through it. So you may not have a time, so you'll have the PowerPoint slides and you can go and work on them. All right, so that's what I was trying to say. Now, I prefer to get the negative values and then change the direction after the equation is done. Yeah, that's good. That's good. Yeah, if that's where you prefer it, yeah, definitely. Definitely. As long as you get the right answer, no worries. Yeah. So again, yeah, guys, I really recommend you, after doing this example, to try the other 3 YouTube videos, to watch them. They are very short. They will be very helpful for you. And you can go through them. All right. Now, hopefully all of you there, we got the support reaction for the 3 forces. So CY, now we can update it, is equals to 16 kilonewtons. And later I will explain to you why I'm doing it that way. So for me, since I found the value, I prefer personally, but again, it's your reference, I prefer to change for the next step. So that's my next step. So I don't need this anymore because you guys have it. I need a space, so I'll just copy it and make it a new slide, so at least we know we don't lose this. So technically, all of this for me, I'll start a new things now, because step 3. So step 3, work using the joint method to find the member force start with the joint with kind of like less unknown. Start with the joint which has less unknown information. So kind of like an idea, so I'm thinking here loud. So if we look to the joints, there is a joint A, there is a joint B, there is a joint C, there is a joint E, and there is a joint D. So we have about 1, 2, 3, 4, 5 joints. So let's start with joint A. So let's say this is joint A. What you need to do, you need to sketch the joint. So this is a force coming from the member AB. So I will say AB. And there is a 4 kilonewtons coming in that direction. And there is a force from that direction is acting. We call it AE. Now, some people, they prefer to write this in that format. It's up to you, honestly. They prefer to write it force, force AB, and they delete this one. And the same thing here, they prefer to write force, but that's again for you, it's some people, they prefer it AE. Okay? Just bring the 4 newtons here. It's showing you now there is a force. Now, one thing I want you to do is to find me this theta. Now you should be, guys, very good in finding angles. So if I say theta, can you find me the value for theta at this point in degrees? So what's the value for theta? So remember what you have here. This distance is 4 meters. And this distance is 2 meters. So kind of we created a triangle here. Can you find this theta? Theta is equals to what? Opposite divided by inverse cosine 2/4. So what's the angle here? Just find me the angle, the value of the angle. The angle is 60. Doesn't sound correct for me. The angle, it's very small compared to 60. Any answer for theta? Come on, guys. I'll sketch it for you so you can know what we're doing. So you will have, this is the normal triangle, but let's rotate it. So you come here, no, 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 yes. Is it that right? No, that's not the right one. Yeah, no, even not this one. I want to rotate that one. It's very funny. This is not the right angle. It's great. Okay. Let's do it in this way, easy. So you have this distance, and you have this distance, and you have this distance. And we want to find theta. So this one is 4 meters. And this one is 2 meters. So go back. Yeah, that's right now. The answer I got from one of you, the angle is less than 30 degrees, correct? So can you tell me? No, it's not. It's between 25 and 30 degrees. Let's make it close like this. So how did I find this angle? Just go back and see what's the things. Yeah, so can you tell me what's equation you're using? So if I want to type it here so you guys can remember it all the time, I don't want you to miss it anymore. So tan inverse what? Open brackets. Can you tell me tan inverse what? Just write 2/4. And that will give you the angle is equal 26.56 degrees. Remember, guys, always when you try to do this, just the formula sheet will be given to you for these equations, but you really need to work it out very well. So tan inverse is equals to what? Opposite to the angle, which is 2 meters, divided by 4. What we call the 4 in the theory or the formula sheet? Yeah, adjacent. So technically, the formula sheet, I'm checking it now. You will get this formula sheet is giving to you for you guys. Perfect. So now 26.56 degrees. That's the angle we're trying to determine here. We don't need any more theta because we found it for us. All right. So here is just working out for you guys how we determine this. I'll move these things here so at least you know where the angle is coming from. That's for the angle. All right, we go back to finding the values. Now, we got the angle. We got the joint A, we call it. So I'll copy the joint. You type like this, joint A, and then just highlight it, put line underneath it, whatever thing. So that joint, that point is joint A. Now, what's next? Next, we need to do summation of forces in X and Y. So technically, this one could be analysis to go cosine and sine. That's what we needed, the angle. Change the color to something easy to see because to avoid any confusion. And this one will be for us like FA sine. Again, when we're going away from the angle, 26.56 will be sine. And the other one will be cosine. So I'll put it here to show you it's going kind of in that direction. And that will be Control-C, Control-V to save my time. And that will be cosine 26. And remember, it's in degrees. Okay? So since we wrote those angles here, it's very easy now for us to use concurrent forces theory because we don't have a moment here. All the forces are passing through one point. So what we say, algebraic summation of forces in X direction and algebraic summation of forces in Y direction. It's easy to start first with the Y direction because we have one unknown, and then we get that value and we go and find it on the other directions and we correct the direction of it. So let's start with that. Insert an equation. So I'll start algebraic summation of forces and then summation. I'll just write the script for this. So we start with F in direction of, we say Y is equals to 0. And remember, because I assume Y is going upwards is positive. So that's the positive direction. So what do I have? I have -4 kilonewtons in blue and minus FAE I'll copy this one to save me time, equals to 0. Rearranging this equation, you get the value for FAE. So can you give me the value for FAE? Equals, so what's the value? Should be negative, positive. So definitely when they are both in negative, then they should be. So 4 divided by sine 26.56, 8.9. Some of you getting the number different from mine. Why? I'm getting 8.9. I'm getting 8.9. How are you getting 9.7? Yeah, it should be minus 8.9. And remember, we're working in kilonewtons. Kilonewtons. No, how come you're getting minus 7? So it just will be, I'll write down the step-by-step the equation. So you will have minus 4 equals the force times sine 26.56. And then that will be equals to F is equal to minus 4 divided by sine 26.56, and that will give you the answer, which is minus 8.9 kilonewtons. So please correct your answer if you're getting less than that. When we're getting negative answer, remember what we assume for FAE is going watts. It's kind of applying as a tension. So we say then if this force is in compression, because it's negative, so it indicates for me it's compressing it, right? Yes, that's good. Yeah, you need to check if you're getting something different, then something wrong either with your calculator or the degrees or radians, or you're not using brackets for the angle or something like that. So that indicates that the direction of this force could go upwards to balance it, which makes sense to get that equilibrium. Now, the same thing we need to repeat is to find algebraic summation forces in the x direction. But how can we do it? So I would do this one. Insert here. Algebraic summation of forces, and then we write here we're doing the fx equals to 0. And remember, since we assume x is going in that direction, it's positive. Therefore, I will take that. Good, you have fixed it. That's awesome. So what do I have? I have the FAB. So FAB, just I'm writing it like that way, plus FAE cosine 26.56. Anything else, guys? Do I have any other force in that direction? See, that's interesting things, equals to 0. Now, here's the question which some of you say, do I change the sign? Do I change the direction of the arrow? It's up to you as long as you follow the process correctly. So I'm not really restricted as long as you get the answer. But see how I solve it first, and then you try it and see if you're getting the same answer. So how I do that? I kept the sign FAE minus 9.8. Now I come here to this equation. FAB is the force we're trying to find, equals, I'll need to substitute. So plus is the equation saying, but I got the FAE is minus 8.9. So I put the minus there, times the angle, which is cosine 26.56 in degrees. So it's just to show you how this works, because you don't want to confuse yourself, equals to 0. Now, it's obviously the negative and plus will be end up to be what? They will end up to be positive. So this will be FAB equals to, when you move that to the other side, will be 8.9 times cosine 26.56 is the angle. This will give you the answer. I'll try it in my calculator at the moment. Cosine 26.56. This will give you an answer, 8 kilonewtons. Very easy. That will give you the answer for the force. So now, because I didn't change the direction of the arrow, because I'm following what I have started with my assumption, since I assumed it's going in that way, but we know it's not anymore is in tension, is actually in compression, as we stated here. Therefore, I acknowledge what I have assumed is wrong. Therefore, I did apply here the negative sign to say, hey, I'm still following my initial drawings, but I'll use the negative sign. Now, the 8 kilonewtons for FAB, the force in blue color, it's actually acting as a tension. So it's a correct sign for it. I don't need to mention anything, but the one in red is actually assumed in the wrong direction. It should be in compression to act in it. So in this way, you kind of acknowledge in a way, but please don't do and go and remove and erase your solutions. No, just say, then this is in a compression. So you're acknowledging the understanding of the negative sign. That's, yes, you're acknowledging you get negative. It's not wrong. It's just as acting on the opposite direction. So this is really, really very important for you guys, because if you do any changes, you may confuse your solutions, and then you get a mistake in the second step, and that will ruin your experience in solving this question. So that's very important. Now, I did it here. You say, then why you did it here? I did it here just to show you the difference on the way how we fix it. When I go and fix it, I don't use the negative anymore. But if I go back to its original, what I have assumed, I must put this is going as a negative. It's either way, both are correct, as long as you don't mix them, you don't confuse yourself with them. So again, they are both correct, but just one could lead you to confusion. The other one is straightforward. My suggestion works with the methods you're comfortable with, and you're getting the right answers. Again, this question is taking a long time, so I will not continue with it. I think that's the end for us for today, especially it's Friday and the weather looks like really good. Oh, it's actually raining. Maybe good for the farmers for the rain. So I will end the recording now, but you're welcome to ask any questions.